Jack with my partner,
Michael Downing,
and we're going to demonstrate a single displacement reaction in Late Nite Labs.
To begin, take a clean 150 milliliter Erlenmeyer flask from the container shelf and place it on the workbench. Next, add 15 milliliters of 6 molar hydrochloric acid from the material shelf to the Erlenmeyer flask. Double-click on the Erlenmeyer flask and select the close to put an airtight stopper on it.
Take a thermometer from the instrument shelf and connect it to the Erlenmeyer flask. Next, you also want to take a pressure gauge and connect it to the flask, also on the instrument shelf. Now, add 0.25 grams of zinc from the material shelf to the Erlenmeyer flask. You can also try this experiment with 25 grams of zinc and see what happens.
The pressure gauge and temperature gauge will allow us, along with visual cues, to determine that a reaction occurs. Notice the bubbling and the change in temperature and pressure. Once the bubbling has stopped, we will allow the Erlenmeyer flask to cool to room temperature of 21.5 degrees Celsius. Notice that the flask has cooled to within 0.5 degrees of room temperature. Now we remove the pressure temperature and the pressure gauge and the temperature gauge. Next, we add a syringe to release and measure the amount of hydrogen gas released from the reaction. We know that the volume of the hydrogen gas is 92.5 milliliters. Next, you clear your entire workbench and move on.
Which can easily be done by going down here and clearing the table. Now let's take a look at the balanced chemical equation for this reaction. We know that 2 moles of hydrochloric acid react with 1 mole of zinc to produce 1 mole of zinc chloride and 1 mole of hydrogen gas. The reason that we have to add 2 moles of hydrogen chloride is because zinc has a 2+ charge, while chlorine has a 1-. So to account for the 2 chloride ions, we add 2 to the hydrochloric acid. Hope you guys learned a little bit about single displacement reactions.